consulting business on there as well, so you can hear about that. And I also help organize the other MPEX, so the one that's in NYC, which hopefully we'll see some of you at. And shout out to all the New York crew who are here today. So it's really good to see everyone. So I work at a company called Frame.io. I'm a director of engineering there, where we basically build review and collaboration software for video teams. So we're used by all these big companies like Vice and Turner and stuff like that. And there's loads of stats here, like 450,000 customers. And we were founded in 2014, and we're based in NYC. And basically what I'm going to talk to you about today is quite a long journey that we've been on over the last year, where we've gone from Ruby on Rails to Elixir and Phoenix. So I'm going to give you like a whirlwind tour of some of that journey. Like, honestly, if they would have let me, I probably could have spoken for a whole day about some of the things we've been doing. And that's not because I like speaking, it's probably because there's just been a lot. So hopefully you'll get a little taste of that today and see some of the great use cases for Elixir in the wild as well. So let's start off by saying, why did we do a rewrite? And why was that in Elixir? So first of all, yes, we did that thing. I'm sure everyone's familiar with this blog post. Sorry, Joel. Yes, we did a rewrite. I'm going to try and justify some of the reasons why we did that today. And actually, Andrew mentioned this really, really well and succinctly earlier about, software grows. Software grows over time, and it gets complex, and it gets messy. And when you're in a startup especially, like, requirements change, right? You're working on one thing one week, the CEO comes to you the next week, and he's like, you know what, we need to pivot. And often the code bases reflect some of that. And that's very, very much the position we were in at Frame.io, with a lot of debt in the code base. So I'm just going to run you through some of the key issues that we had. So it was a Ruby 1.9.3 app, running Rails 3.2, two major versions out of date now for anyone who keeps up with the Rails community. So it had no tests, none at all for anything in the app whatsoever. Which also coincidentally makes rewriting it quite difficult, but I'll get to that in a bit. So it also had this custom RRM that was backed onto DynamoDB, which you might be thinking, well, that's quite unusual given that Rails comes with this framework called Active Record, and yes, it was quite unusual. So this talk's recorded, and I'm going to feel really bad for our CTO, who wrote quite a lot of this, but hopefully he won't watch. So there was a lot of meta-programming everywhere across the app. Like, it takes you a really long time to trace any calls to see the source of them. There was absolutely no logical separation of any aspects inside of the application. So being a collaboration app, it's all about what can you access and when and how. And there was none of that. It was very much your classic MVC, put everything in the models and have really fat controllers. And also there's no metrics or visibility into the performance. Okay, so that's the API side. Let's just touch on the database side. So I mentioned that it backs into DynamoDB. So for those of you who are familiar with DynamoDB, it's a key value store, effectively like a NoSQL key value store, right? So it's really, really good for horizontally scaling, except we weren't using it in that way whatsoever. So everything was a string, everything. Even nulls. There's a value called JT null value, which is a null, apparently, but also a string. All of our foreign keys were stored on the entity, but encoded as a JSON list. So everything, nothing could be updated atomically. So we would actually drop customers' data left, right, and center if there was two updates happening at the same point in time. And DynamoDB cost us a lot of money to run this workload. So, and then to top it all off, no pagination whatsoever because of the way DynamoDB was structured, which resulted in some of our largest customers having response times of up to 45 seconds. And that's no exaggeration. Like, I literally had to up the load balancer timeout to 45 seconds to make sure